Question number 71. Volume of water required to prepare 0.1 molar solution of 1.6 liter 0.2 molar solution of KOH. It means you already have the molarity here for a particular solution. With the help of that, you're just going to prepare another solution. In that solution, you need to just add certain amount of water. It means in this case, we'll use the equation for dilution, that is molarity equation. And what's that? M1V1 is equal to M2V2. So first of all, we'll find out the actual volume required there. So volume of the water required to prepare 0.1 molar solution from 1.6 liter 0.2 molar solution of KOH. So basically in this case, already we have 1.6 liter M1 and V1 are given. V1 I've already written here. M1 is 0.2. And what you need to do here, you just want to change its molarity to 0.1. Now what would be the volume here? V2. That V2 is equal to 0.2 into 1.6 divided by 0.1. This would be. So it gets changed into 3.2 liter. V2 is 3.2 liter. Already 1.6 liter is available. So how much water you need to add? So volume of water required to be added for the process of dilution is equal to 3.2 minus 1.6. That's very simple. 1.6 liter you need. And where this is given? This is given here in option 3. So just choose that as your correct answer. After this, another question. Now question number 72. From 44 mg CO2, 10 raised to the power 20 molecules are removed. Calculate the moles of CO2 left. Use Na. That's equal to 6 into 10 to the power 23. It means Avogadro number is also given in the question. In this case, you have the mass of CO2. What's that? It is 44 mg. But to convert it into moles, what you need? You need mass in grams. That's why I'll just change it. It becomes 44 into 10 raised to the power minus 3 gram. With the help of this, I can find out the number of molecules of CO2 also. So number of molecules of CO2 would be equal to given mass by the molar mass of CO2. What's that? That is 44. You know that. And just multiply what? Avogadro number. That is given in the question. I'll just underline it. It is 6 into 10 raised to the power 23. So I'll just multiply directly 6 into 10 raised to the power 23. So these are the number of molecules of CO2 present there. It can be simplified and written as 6 into 10 raised to the power 20. Because this is 23 and this is 10 raised to the power minus 3. So it becomes 6 into 10 raised to the power 20. These are the number of molecules of CO2. Now what is done here? In this case, you have just removed 10 raised to the power 20 molecules. Left CO2 molecules. What would be those molecules? These would be 6 into 10 raised to the power 20 minus 10 raised to the power 20. This. So I'll just take here 10 raised to the power 20 as common. It becomes 6 minus 1, that is equal to 5 into 10 raised to the power 20. These are the number of molecules, but this is not the question. Question is to find out the number of moles of CO2. So I'll just write here moles of left CO2. This is equal to N by Na. N is the number of molecules, those you have. And just divide it by Na value. Once again, 6 into 10 raised to the power 23. You are dividing by it. It will become 10 raised to the power minus 3 that you will obtain here into, and if you divide 5 by 6, the value is approximately 0.83 that I can take here, and that could also be written as 8.3 into 10 raised to the power minus 4. Where this value is given? This is correctly given here in option 2. So just choose option 2 as your correct answer. After this, another question that I have. For the hypothetical reaction, 2A is reacting with 3B and reacting with 4C to give you 2D. Maximum moles of D formed when 10 moles of A reacts with 9 moles of B and 16 moles of C are. Simple question based on limiting reagent. So find out what is limiting reagent here. So 2D. In this case, it's clearly written that 2 moles of A, on the basis of stoichiometry I'm just writing, 2 moles of A are reacting with 3 moles of B. So among these two, if I just want to find out which is limiting reagent, so we have to look at the given data. 10 mole of A, 9 moles of B and 16 moles of C. So in this case, 2 moles of A reacting with 3 moles of B. So if you have 10 moles of A, then as per stoichiometry, as per question, how many moles of 3 are required here? These are 3 by 2 into 10, or it can also be written as 15 moles. And how many moles are available? These are required moles. And what are available moles here? These are 9. 15 are required, 9s are available. It means definitely among A and B, B is acting as limiting reagent. So on the basis of that, I can write here among A and B, B is limiting reagent. Now it's a turn for comparison of B and C. So as per the reaction, once again I'm just doing the same thing. As per the question, 3B requires 4C. On the basis of that, we can simply say if available moles of B are 9, then for that 9 B moles, you need 4 by 3 into 9, and that is equal to 12 moles of C. And what are available moles of C? Available moles of C, I'm just writing here. Those are 16 moles. So now on the basis of this, B is finally the limiting reagent that we obtained. On the basis of that, we have to once again apply the stoichiometry. 3B is producing 2D. So as 3B is producing 2D, then definitely in this case, how many moles of D are produced when you have 9 moles? So if 9 moles of B are there, then you will obtain 2 into 9 by 3. It means 6 moles of D would be produced. So definitely the answer is option 2, in which 6 moles are given. Now after this, question number 74. Maximum number of electrons in an atom having N plus L plus M value that's equal to 3 is. In this case, we have the 3 quantum numbers N, L and M, and their sum is equal to 3. N is principal quantum number, we know. L is azimuthal quantum number and M is the magnetic quantum number. And the value of L is dependent on N. L value is from 0 to N minus 1, that we know. And if I talk about M value, that depends on the value of L. It is from minus L to plus L value. So this we need to know. Now in this case, if I'm just considering the sum of these 3 is 3, then definitely N value can be either 3 or it can be 2. So if N value is 2, then in that case L value should be 1. But if these two are giving you the sum as 3, then definitely m value should be 0. And we know that if n value is 2, then L value can be 0 to n minus 1. So 1 can be the value. Similarly, if I talk about m value, that is minus L to plus L, and 0 is also there. That's why I'm taking 0 value here. So this sum will give you 3. After that, if n value is 3, then L value should be 0. Then the sum would becomes 3 and m value should also be 0. And it is possible because L value depends on n and that is equal to 0 to n minus 1. Similarly, m value is from minus L to plus L, then 0 is definitely there, and on that basis this sum will becomes 3. After that, if it is 3, L value can be 1, but this will give you the sum 4, but you don't need 4, you need 3. So if m value is minus 1, then definitely the sum will become again 3. Similarly, if n value is 3, then L value can also be 2. So this m value should be minus 2. From minus 2 to plus 2. That's why I'm taking value minus 2. So all these 4 quantum numbers are representing here n plus L plus m is equal to 3. And if I talk about the number of electrons associated with that, definitely with each of these set of quantum number, 2 electrons can be associated with plus half spin and minus half spin. It means if 4 set of quantum numbers are there, then definitely if each of this set is followed by 2 electron, then total number of electron associated with this would be 8 electron can be associated with that. And on that basis, definitely option 3 becomes the correct answer for this question. After this, now here's question number 75. If the potential energy of the first orbit of hydrogen atom is 0, then the total energy of the electron in third orbit is. First of all, I just want to consider here the general case when the actual potential energy we are considering. So total energy for a particular orbit, if you want to find out, that is the sum of the kinetic energy and the potential energy. Now the formula for the total energy, I just want to tell you, that is equal to minus 13.6 z square by n square, and that is in electron volt per atom we are talking about, the unit that we should use. Now potential energy is equal to minus 2 into 13.6 z square by n square. Similarly, if I talk about kinetic energy, that is equal to 13.6 z square by n square, electron volt per atom. These are the formula. Now in general case, the energy of kinetic energy we are talking about, kinetic energy of third orbit if we talk about, that would be equal to 13.6 into z square, that's 1 square, by 3 square. So this value is equal to 1.51 electron volt per atom. Similarly, if I talk about the potential energy for the general consideration, that should be minus 2 into 13.6 z square, that's 1, by 3 square, that's 9. This is the value. Now we know that potential energy can be represented with the help of the reference, because potential energy is mgh, h value is important there. It means the energy associated with first orbit is also affecting the potential energy associated with third orbit. So if I talk about the potential energy of first orbit, what would be the value? Very simple, it is equal to 2 into 13.6 into z square, that is 1 square, by n square, n is 1 also, so this would be the value. But as per the question, it is said here that if the potential energy of the first orbit of hydrogen atom is 0, it means they are just considering this value is now 0. Then what will happen? We know that for the consideration of the potential energy, we need certain reference, and here the reference is the potential energy of the first orbit, that is assumed to be 0. It means this factor, this minus 2 into 13.6, that value it is assumed to be 0. It means this factor should be added in the potential energy of the third orbit, because now the value has been changed. So on this basis, potential energy of third orbit will be equal to minus 2 into 13.6 by 9 plus 2 into 13.6. If you calculate this, you will find out this value is 24.17 eV per atom. Now it's a turn for the calculation of the total energy. What would be that? Total energy is equals to kinetic energy plus potential energy. Kinetic energy we already calculated, 1.51. Because kinetic energy remains same, it would not be affected if you are changing the potential energy of the first orbit further. In this case, potential energy we find out 24.17, and this value will give you the final answer, that is 25.68 electron volt per atom. Where this answer is given? This is correctly given here in option 4. So just choose option 4 for your question. I hope this is clear to you. Let's take next question.